Hi everyone, my name is Vibha Thomas and today I'll be demonstrating my project, which is Smart Wearable Textile Platform for Health Monitoring. Now these are the devices that I used for the project, and what I'm going to demonstrate now is remote access control from my laptop to the Raspberry Pi as shown in this video. Here, as you can see, that my keyboard and my mouse is connected to the Raspberry Pi and displayed on the monitor, while you can remotely access the Raspberry Pi terminal and the entire Raspberry Pi device through my laptop. So here I can type into the terminal from my laptop. So here we go to connect.raspberrypi.com, log in through your credentials, and there are two ways of connecting, that is screen sharing and SSH. Now waiting to connect, and finally here we can see that the device, this is the terminal, and going to the code file, which is the Pi sensors, all the sensors that are connected. I've created a class to manage the sensors. We have the DHT sensor defined, we have the ECG module sensor defined, and we have the beats per minute defined, where I've actually normalized the values for beats per minute, which you will understand shortly. This is the agent file, this is the task file, the task that the agent needs to do for health, the temperature monitoring and ECG monitoring, as well as the output file. Next, coming to the tools that I use. So to verify our AI resource, we implement RAG through Vertex AI. So we have a legitimate resource and make our AI very reliable. So the main agenda about this project is to implement Edge AI and Agentic AI onto the device, which is basically Edge AI or Edge Inference, to implement local processing without any internet. And you get Edge Inference, meaning you can process immediately and you don't need to wait for medical assistance, and it can always be verified later, but for immediate support you can always have Edge Inference. Now coming to the demo, so this is the UI. I've created the UI using Streamlit, and it takes a few minutes to show the values for the sensors to kick in. So like I mentioned earlier, I have normalized the ECG monitoring. So if you notice, I have removed the noise. So whenever there's any small movement, the voltage that is captured is very sensitive. So there are a lot of fluctuations if I move. So soon in the video you will see when I'm trying to move, and there are a lot of fluctuations, but the value has been normalized to remove all the noise. So here I'm just going to enter the patient's name, that's me, and let's trigger a local analysis. This is for hypothermia, which is at 33 degrees, usually when the normal body temperature is between 36.5 to 37.5. So here you can see my agent is running locally, and I'm trying to increase the temperature using my DHT sensor using my light. Now you can see there's a report that's come from my agent which shows hypothermia and normal heart rate, and this is local, it does not use any other inference. So let's just take a screenshot of how beautiful the report has come out. And now when you notice, the graph is very, very spiked up. That's because I'm trying to take a screenshot, and there's a lot of movement in my body, that's why it's fluctuating a lot. But I've removed all that noise, and that's how the beats per minute reading, that's the heart rate, is capturing only the vital data, that is the heart rate. Now moving on to the RAG verification implementation that I've made. So based on the data that we're getting. So I've asked, are there any abnormalities? And it says the heart rate is normal, but the heart rate and the temperature is normal. That's 36.0 and 77.77 beats per minute. So there are no abnormalities. That's because I made sure that the temperature, I tried to simulate a human body temperature using DHT sensor. So coming back, let's try, we tried hypothermia, normal temperature, and let's try for a higher temperature. I think now you can download this. So what I've implemented is you can download the report from the edge itself. So whatever my agent from the device has processed, that you can download as a PDF, which is shown here. And yeah, this one's the hypothermia one, just confirming it's 33.5, and the report also shows the same, which we triggered. And now we've increased the temperature to 38.5, 30, which is pretty high, 39. So let's trigger it again. And the crew has started, agent has started. So there are 3 agents. And yeah, it's come up with the report again, where the temperature is 39 degrees, which it says it has fever. We have 77 BPM, which is normal, and this is the clinical assessment where there's severe fever and the RAG evidence. So yeah, now let's move on to our RAG chat, which I've implemented using Vertex AI. So now I'm asking, are there any abnormalities? And it says yes, there are a lot of abnormalities. Your temperature is pretty high. It's 40, 43 or 41 degrees. So I'm asking, what are the causes of these readings, and what could be the symptoms? So when you notice, this is not being run locally. We're actually using the Vertex AI RAG engine that Google has provided, and we've come up with great response, where it says that the temperature is really high, but your heartbeat is pretty normal. You can possibly have severe infection, headache, or these are the symptoms, and it's a beautiful output. So this is basically the entire project demonstration that I've done and tried to simulate normal reading. Thank you.